Hey folks, Bill Armstrong here. Thought I'd put together a video for the beginnings of the next material where we're going to start looking at the graphs of the trigonometric functions. And before we get started on the graphs, just wanted to kind of review again probably the most important structure in trigonometry, the unit circle. Recall that on the unit circle, x-coordinates of these points I have labeled around the unit circle tell you the cosine, y-coordinates of these points tell you the sine. So these points that are around the unit circle happen to be where the special angles intersect the unit circle. You know, the special angles like pi over 6, pi over 4, pi over 3, 2 pi over 3, etc. So let's just, I'd like to review that concept real quick as it transitions into looking at the graphs of the trigonometric functions. So first thing I'd like to do to kind of make this transition is, say I ask, or someone asks you to find the exact value of sine of pi over 6. From the unit circle, we just have to know, where does pi over 6 terminate? Where does that angle pi over 6 terminate? And we know pi over 6, if I were to sketch it in standard position, is that angle right there. It intersects the unit circle at that point. So this is the angle pi over 6. So the sine of pi over 6 is just simply the y-coordinate of this point. So the y-coordinate of this point is 1/2. So the sine of pi over 6 is simply 1/2. Well, what if you were asked to give the exact value of the sine of 13 pi over 6? Okay, at first glance, I don't know where 13 pi over 6 is on the unit circle, but I do know 13 pi over 6 is larger than 2 pi. In fact, 13 pi over 6 is an angle that, if I were to sketch it here, it's an angle that is coterminal with pi over 6. Well, since 13 pi over 6, if I were to sketch it, it would look like this. It'd go all the way around. Boom. There's 13 pi over 6. So the sine of 13 pi over 6, it's still going to be the y-coordinate of that point on the unit circle. And that's because pi over 6 and 13 pi over 6 are coterminal angles. So we would have the sine of 13 pi over 6 is 1/2. I could continue this and ask, okay, well, what's the sine of 25 pi over 6? Well, 25 pi over 6, that is an angle that is also coterminal with pi over 6. I'm not going to sketch it up here. I'll just kind of show you what it would look like. All the way around 2 pi. There's 13 pi over 6, and I would go around. I go around a couple of times, maybe get a little dizzy, but that would be 25 pi over 6. 25 pi over 6 is coterminal with pi over 6. So where the angle 25 pi over 6 would intersect the unit circle, it's the same y-coordinate. It's still 1/2. So this coterminal angle business, as I just illustrated here, matches up with the key concept when we start to graph the 6 trig functions, and it's called the period. Period is, and I'll define it here in a little bit, but in short, period is just going to be, the length of the interval where things start to repeat themselves. But I'm going to use this as a transition into, looking at the graphs of, here at first, just sine and cosine. All right, here we are, folks. This is the basic graph, or the general shape of what the graph of sine would look like. The graph of the function sine x. What I've done here is I've shown the graph of sine x over what's called 2 periods. I could I could graph it over 3 periods, 4 periods, etc. But this is the graph over 2 periods. And I wanted to get the graph of 2 periods up here to show the repeating behavior, the cyclical nature of the graph of sine. And that's kind of go back to the unit circle. But notice from here to here, we look at the graph of sine. Notice that that shape is repeated over here. It's got the same shape. And then it's repeated again. And then it would be repeated again, etc., etc., as I would do more periods. For this reason, I'm going to tell you that, or you will see that the period of sine x, basic graph of sine x, is 2 pi from here to here. The length of that interval from 0 to 2 pi, well, the length of that interval is 2 pi. And if I know the graph over 1 period, I know what the graph looks like everywhere because it's just going to repeat itself over one. If I know the graph over 1 period, I know what it looks like everywhere because it keeps repeating itself. For example, if I just look at the graph from negative pi to pi, just this piece of the graph, that's a length of 2 pi. That's a period of 2 pi. If I look at this shape in here, it's going to be repeated. But what I would like you to know, when you hear basic graph of sine x, I would like you to know the basic graph of sine x from 0 to 2 pi. In other words, this piece right here, that's what I'd like you to think of when you hear basic graph of sine x, is that shape right there. And on this basic graph of sine, I'm going to highlight 5 points. I might call them 5 key points. I think your text might call them 5 quarter points. But here are the 5 key points, or 5 quarter points. It's this point, I don't know if this will show up, use a red colored chalk. It's this point here, which is 0, 0. It's this point up here, which is the point pi over 2, 1. It's this point here, pi 0. This point here, 3 pi over 2, negative 1. And it's this point here, 2 pi 0. Notice that these 5 key points, or your book calls the 5 quarter points, it's where the basic graph of sine either has an x-intercept, reaches a maximum value, or reaches a minimum value. Here in a little bit, I'm going to start calling these 5 key points, or 5 quarter points, I'm going to call them slightly different things. In other words, I'll call this point here the left end point of 1 period, and I'll call this point the right end point of 1 period. Then the point that's in the middle, well, I'll just call that the midpoint. The point that's between left end point and midpoint, I will call that the first quarter point, and your book does too. And then I'll call this point here the third quarter point. And those are going to be very key in graphing any type of sine function, no matter how we want to manipulate it. So to recap, basic graph of sine. I want you to know it's this piece right here, and that it has a period of 2 pi. Hey folks, here we are looking at the basic graph of cosine. I've quickly sketched up here the basic graph of cosine over 2 periods. So this is the basic graph of the function cosine x. And again, I've initially sketched it over 2 periods so we could see the cyclical behavior, the repeating behavior of the graph of cosine. It's over 2 periods, but just like sine, just like the graph of sine x, I'll show you the region I want you to know, or I want you to think of when you hear basic graph of cosine x. I'd like you to think of it, this piece right here, that this is the basic graph of cosine x on the interval 0 to 2 pi. Notice on the interval 0 to 2 pi, that shape, notice how it's repeated over here? It would just keep repeating itself forever and ever. For that reason, just like sine x, the basic graph of cosine, it too has a period of 2 pi. So I'd like you to know what I'd like you to think when you hear basic graph of cosine. I would like this to pop into your head. I would also like you to see, just like with the basic graph of sine that we just looked at, there are 5 key points here that your book calls the 5 quarter points. And just like with the basic graph of sine, notice that x-intercepts, maximum, minimum. So I'd like you to know that those 5 points, and you'll see here in a little bit, I'm gonna be giving these 5 quarter points. I'm gonna be calling them slightly different things. I'm gonna be calling this one the left end point of one period, and I'll call that one the right end point of one period. The one in the middle, between the left end point and right end point, I'll call it the midpoint. That would be the first quarter point. That's the third quarter point. But I'd like you to think, I'd like you to know, when you hear sine, graph of sine over one period, basic graph of sine, or basic graph of cosine, I'd like a certain picture to pop into your head. One final comment is the basic graph of sine, it is called the sine wave. Some people say that the graph is sinusoidal in nature. I don't like that word, but a lot of people call it that. So I'll say it's a sine wave. We call the basic graph of cosine, we say it too is a sine wave. We don't call it the cosine wave. It's just called the sine wave. So in general, any type of graph you would look at that would have this type of shape to it will be given the name, it's a sine wave. So that's the basic graph of cosine x that I'd like you to know. Let's take a closer look now at the 5 key points, or the 5 quarter points. All right, folks, real quickly, the 5 key points, or the 5 quarter points, it's going to be an important skill that we can determine these split points, or the quarter points, or the key points. So I thought I'd do a quick example to show you how friendly this is. If I'm asked to determine the 5 key points of the interval pi over 2 to 5 pi over 2, here's what that's all about. If I actually first think of this interval as being some region on my x-axis, so here's pi over 2, and here's 5 pi over 2. We already have 2 of the 5 key points. You already have 2 of those 5 quarter points. You have the left end point of the interval and the right end point of the interval. So what's left? What's left is to get the midpoint and then the first quarter and third quarter point. Here's how I would do it. It's formula free. I know in the book you will see a formula on how to do this, but this makes it formula free. If you just remember midpoint between left end point and right end point, finding the midpoint, it's like finding the average of those two. It's like finding the average of pi over 2 and 5 pi over 2. So how do you find an average? How do you find a midpoint? Well, you simply add these together and then divide by 2. Add these together and take half of that. So if I add these two together, see, pi over 2 plus 5 pi over 2, well, that's 6 pi over 2, which reduces down to 3 pi. If I take half of that, I get 3 pi over 2. So that means this midpoint here is 3 pi over 2. So the 2 remaining quarter points to find are the first quarter point and the third quarter point. notice the first quarter point will be the midpoint or halfway between pi over 2 and 3 pi over 2. So how do you get the midpoint between pi over 2 and 3 pi over 2? Well, it's like finding the average. You just add these together and take half of that. You just add them together. See, I'll try that over here. Pi over 2 plus 3 pi over 2. That gives me a 4 pi over 2, which is 2 pi. Take half of that. Gives me pi. The first quarter point's pi. How do I get the third quarter point? That's right. It's like finding an average. It's the midpoint between here and here. So you take the average of this number and this number. So you would take 3 pi over 2 plus 5 pi over 2. You would add those together, which gives you 8 pi over 2. 8 pi over 2 reduces down to 4 pi. Then you would take half of that. It's the same process. Take half of it. And that gives you 2 pi. And that's the interval pi over 2 to 5 pi over 2. Those would be the 5 key points, the 5 quarter points. And I will, here soon, I'll start calling on the interval pi over 2 to 5 pi over 2. I would call this left end point, and I call that right end point. That's the midpoint, the first quarter point, and the third quarter point. So that was a quick example to show you how friendly it is to really find what your book calls these 5 quarter points. And I did it in a manner that made it kind of formula free, kind of went back to something I already knew, how to find a midpoint, which is just like finding an average. All right, the next thing we'll look at as we begin to graph more exotic looking trig functions, not just the basic graph of sine or cosine, is this thing called amplitude. Now in a prior math class, and the class before this is college algebra, it would have been called vertical stretch or vertical shrink. So in college algebra it would have been, the vertical stretch or the vertical shrink. In trig, we don't call it vertical stretch or vertical shrink. We give it a special name. It's called amplitude. So in general, if you are looking at the function a times sine x or a times cosine x, the amplitude of the graph, or how much it's stretched or compressed, the amplitude of the graph is simply the absolute value of whatever a is. Okay, let's look at a quick example of graphing a basic trig function with a little amplitude involved. All right, here we are, folks. We're going to look at sketching the graph of y equals 2 sine x. In my directions, like on a test or whatever, on a test, I would have you graph over one period the graph of whatever trig function I'm asking you to graph. Because again, remember, if I know the graph over one period, I know what it looks like everywhere. The graph, its shape over one period will just simply be repeated. So I only need to see the graph over one period. For right now, I can tell you this one here, it still has a period of 2 pi. But what is different? Well, we have a 2 out front. That means the amplitude is 2. Amplitude, I'll abbreviate that as AMP, is the absolute value of whatever that number is, which is 2. So the amplitude here is 2. Now the effect that has on the graph, let me get my important points in here. Remember your basic graph of sine. The basic graph of sine is doing something like this. That's the basic graph of sine. With an amplitude of 2, and I'll go back to what you learned in college algebra, That's just going to stretch it by a factor of 2. So I should be able to plot points. I should be able to plot exactly where points would be on this graph. And I'm going to show you really why these, what your book calls the quarter points, why I call them the key points. And it goes back to the unit circle. If I'm going to plot points, in fact, let me sketch a quick unit circle up here. That's not too bad for me. We'll pretend, we'll call that a circle. If you go about the process of plotting points, I would say what you do is, let's toss 0 in here for x. You're going to plot points. So you take 0, toss it in for x. And to determine y, you have to know what the sine of 0 is. Well, the sine of 0 is the y coordinate of that point. We know the coordinates of that point are 1, 0. So the sine of 0 is 0. 2 times 0 is 0. So when x is 0, y is 0. So, I'm sorry, when x is 0, y is 0. So I can come in here and plot 1 point. Boom. Move to pi over 2. If you're plotting points, pi over 2 would come in here for x. So you have to know what is the sine of pi over 2. Well, in the unit circle, pi over 2 terminates right here. The sine of pi over 2 is the y coordinate of that point, which is 1. So 2 times 1 is 2. So that means when x is pi over 2, y is 2. Pi. You put pi in for x. The sine of pi is, well, here's where pi terminates on the unit circle. So it's the coordinate, knowing the y coordinate of that point, which is 0. 2 times 0 is 0. So when x is pi, y is 0. So you'd plot that point. Continuing, when you put 3 pi over 2 in here for x, the sine of 3 pi over 2, well, if you know 3 pi over 2 terminates here, it's knowing the coordinates of that point right there. The sine of 3 pi over 2 is negative 1. 2 times negative 1 is negative 2. So you could plot the point down here. And finally 2 pi. The sine of 2 pi, well 2 pi is 1 trip around the unit circle. Sine of 2 pi is 0. 2 times 0 is 0. You've plotted 5 points. Connect those 5 points with the smooth curve. And that would be your graph of 2 sine x. That's the graph of 2 sine x over 1 period. Let's look at another one. Let's do one more example. So give me a minute to erase this. So let's sketch the graph of negative 2 sine x over 1 period. First thing I'd like to do is determine what is the amplitude. Well, the amplitude is the absolute value of negative 2, which is 2. Now, some of you may remember from college algebra, putting that negative sign out front would take the graph of 2 sine x, which we just did, and kind of flip it around the x-axis. But I'll pretend like I don't remember that from college algebra. Once I know the amplitude is 2, so I'm going to come in here and I'm going to sketch the graph over 1 period. So 0, here's 2 pi, pi over 2, 3 pi over 2. Get some scaling here on my y-axis. Let's go through the process of just plotting 5 points, the 5 key points, 5 quarter points. Put 0 in for x. Sine of 0. It's the y coordinate of that point there. Sine of 0 is 0. Negative 2 times 0 is 0. So there, we plotted 1 point. Put the first quarter point in here for x. Sine of pi over 2. Well, here's pi over 2. The sine of pi over 2 is that y-coordinate, which is 1. Negative 2 times 1 is negative 2. So I plot that point. Sine of, put pi in for x. Sine of pi. The sine of pi is 0. Negative 2 times 0 is 0. So I plot that point. Put 3 pi over 2 in for x. The sine of 3 pi over 2. Sine of 3 pi over 2 is negative 1. Negative 2 times negative 1 is positive 2. So I plot that point. And finally put 2 pi in for x. The sine of 2 pi is 0. Negative 2 times 0 is 0. Connect the 5 key points with the smooth curve. Make that bigger so I hit it. And that is your graph of negative 2 sine x. And you can just look back at the last example we did, part A, which is the graph of 2 sine x. Note they both have the same amplitude of 2. And notice that this graph is nothing more than the graph of 2 sine x flipped around the x-axis. But I didn't need to remember that part from college algebra. I just kind of did it. All right, folks, next thing we're going to look at is how to change the period. In college algebra, you would have called that like a horizontal stretching a graph out, or a horizontal compression. In trig, this horizontal stretch or horizontal compression, I mean the name for it is going to be called period. So it's like if we take the basic graph of sine and we compress it in, or we take the basic graph of sine and we stretch it out. That's going to be changing the period of the graph. So let me write it down one more time, or stuff that I've said about period. So I'll write it down. I'd like you to think period is nothing more, and I've said this several times already, the length of the interval that you need to see one complete cycle of the graph. So it's the length of the interval that you need to see one complete cycle, because if you can see one complete cycle of the graph, then you know what it looks like everywhere, because it's just going to keep repeating itself. In general, if you see y equals sine of bx, or y equals cosine of bx. So now you'd have a number living here in front of the variable x. It's a number living in front of the variable x. When you see that, the period will be found by taking 2 pi and dividing it by b. So that's how you're going to find the period of whatever function you're asked to graph. This little formula, 2 pi divided by b. So let's see how this works in an example. All right, here we are. Let's graph over one period, y equals cosine 1/2 x. Now what I would do here is, the first thing I would do is determine, well, what is the period? I'm asked to graph it over one period, so what is the period? What is the length of one interval that I need to be looking at here? So the period, keep in mind the period is found by doing 2 pi over b. Well, b is 1/2. See right here, that's your b, 1/2. So for this problem, the period is 2 pi over 1/2. Yeah, that looks horrible. Why don't we clean that up? 2 pi over 1/2, that's 4 pi. So that is the period of this function. It'll be the period of the graph. It is 4 pi. So now, tying it back to those key points and determining the key points, or the quarter points, if you will, what I will do is I will start off here by laying off one period on my x-axis. The period is 4 pi. For right now, the left endpoint of one period is 0. The right endpoint is 4 pi. That's a length of 4 pi. So how do we find those three other key points? Right now we have the left endpoint and the right endpoint. How do we get this midpoint? Well, it's the average. It's the midpoint between these two. It's the midpoint between 0 and 4 pi. How do you find the average? Add these together and divide by 2. So 0 plus 4 pi is 4 pi. Half of 4 pi is 2 pi. The first quarter point is halfway between the left endpoint and the midpoint. So how do you get the point that's halfway between 0 and 2 pi? That's right, add them together, divide by 2. So 0 plus 2 pi is 2 pi. Half of 2 pi is pi. The third quarter point? Well, the third quarter point is halfway between the midpoint and the right endpoint. This point here is halfway between 2 pi and 4 pi. Add these together and divide by 2. So 2 pi plus 4 pi is 6 pi. Half of 6 pi is 3 pi. And now I'm going to plot. I'm going to plot these 5 key points. So let me sketch up again the unit circle. I mean, the unit circle in these 5 key points, folks, it should keep coming back to the 5 easiest points on the unit circle. For example, let's start off. We're going to plot points. 0. 0 goes in here for x. We're trying to find the y coordinate. So 0 comes in for x. 1/2 times 0 is 0. Cosine of 0. Well, the cosine of 0 is knowing the x coordinate of that point, which is 1. So cosine of 0, 1. So I can plot that point. Move to this point, pi. Pi comes in here for x. 1/2 times pi is pi over 2. Cosine of pi over 2. So cosine, we have to know pi over 2 is here. Cosine of pi over 2 is the x coordinate of that point, which is 0. So quick observation, notice that this first quarter point, when we took this first quarter point and put it in here for x, it dropped us off on the unit circle at that point that is a quarter of the way around the unit circle. Kind of cool. Next up, 2 pi. Put 2 pi in for x. 1/2 times 2 pi is pi. Cosine of pi, well, here's pi. Cosine of pi is that x coordinate, -1. So we plot this point down here. Notice 2 pi was the midpoint of our period. And when we put 2 pi in here for x, it dropped us off on the unit circle at the point that was halfway around the unit circle. Kind of cool. Next up, put 3 pi in for x. 1/2 times 3 pi is 3 pi over 2. 3 pi over 2 is here. The cosine of 3 pi over 2 is that x coordinate, which is 0. Plot that point. That's your third quarter point. Notice when you put 3 pi over 2, when you put 3 pi, the third quarter point, in here for x, notice on the unit circle it dropped us off at the point that was 3/4 of the way around the unit circle. Kind of cool. Go ahead and put 4 pi in for x. 1/2 times 4 pi is 2 pi. To get the cosine of 2 pi, we go all the way around. Cosine of 2 pi is 1. Plot the point. And now we connect these 5 key points with a smooth curve. And we get a graph that looks something like that. That's the graph of y equals cosine 1/2 x. So it took the basic graph of cosine from 0 to 2 pi and see it just stretched it out. That's it for that one. Okay, finally, folks, let's put these two things together that we've talked about, the amplitude and the period. So if you're asked to graph y equals a sine bx or y equals a cosine bx. For either one, we know the amplitude is the absolute value of A. The period is found by doing 2 pi divided by B. So that's putting everything together that we've done. And let's try to do one example. Let's say you're asked to graph over one period y equals 4 sine of 3x. So the first thing I would do is I would note, well, the amplitude is absolute value of 4, which is 4. The amplitude is the absolute value of that number. The period, well, we know the period is found by doing 2 pi divided by b. Well, b is 3, so the period is 2 pi over 3. So to get the graph, I will lay off one period on my x-axis. The left end point for the time being, all of them we've looked at, the left end point's been 0. The right end point is 2 pi over 3. So we have 2 of those 5 key points. Let's find the other 3. There's left end point, there's right end point. Get the midpoint. How do you get midpoint? Add these 2 together. Well, divide by 2, or add those 2 together and take half of that. And if I do that, I'll get the midpoint to be pi over 3. First quarter point, well, that's halfway between the left end point and the midpoint, so I add those 2 together and take half of it. Gives me pi over 6. Third quarter point, well, that's halfway between pi over 3 and 2 pi over 3. So I add those together and take half of that, and that gives me pi over 3 plus 2 pi over 3 is 3 pi over 3, or which reduces down to pi. Half of that is pi over 2. Amplitude is 4, so I think on my y-axis, my graph, my y-axis isn't very large here, so let me say this is scaling by 1s. And there's -4. And I'm going to plot points because I want to show one more time why these are called the 5 key points. It's also setting up when we start to do more exotic things to these graphs, like shifting them horizontally. But we're not there yet. So let me sketch up a unit circle one more time. I cannot stress enough how important the unit circle is. If you're going on to calculus, it's so important to know the unit circle. But here we go. Start off, going to plot points. Put 0 in here for x. 3 times 0 is 0. Sine of 0, 0. So 4 times 0, okay, there's 1 point. Now notice pi over 6. When pi over 6 comes in here for x, it gets multiplied by 3. 3 times pi over 6 is pi over 2. The sine of pi over 2. Well, pi over 2 is here. Sine of pi over 2 is that y-coordinate, which is 1. 4 times 1 is 4. Again, note the first quarter point. When we take that x value and toss it in here for x, notice that when we multiply it by 3, it's dropping us off at this very friendly point on the unit circle. The point that's a quarter of the way around the unit circle. Continuing, put pi over 3 in for x. 3 times pi over 3 is pi. From the unit circle, I know the sine of pi is 0. 4 times 0 is 0. So I can plot this point. Next up, pi over 2. Third quarter point is pi over 2. Put pi over 2 in for x. 3 times pi over 2 is 3 pi over 2. From the unit circle, I can see the sine of 3 pi over 2 is -1. 4 times -1 is -4, so that's down here. Finally, when 2 pi over 3 comes in here for x, 3 times 2 pi over 3 is 2 pi. The unit circle tells me the sine of 2 pi is 0. 4 times 0 is 0. Gives me that point there. Connect those 5 points with a nice smooth curve. And we get something like this as the graph of y equals 4 sine 3x over 1 period. So that's like a quick overview of the basics of basic graphs of sine and cosine with a little amplitude and a little period change. Thanks for watching.